5.5, number 307. We have the definite integral from 0 to root pi of t cos t squared sine t squared. So it's not the trigonometric function which is being squared, but the variable inside in both cases. dt. Alright, so again, I always mention that try to make the u substitution the part that looks like it's been composed, so parentheses tend to give that away, so I'm going to try the t squared. And this makes some good sense because once I take the derivative, du is 2t dt, and I see a t dt left over. Right? So we'll have that 1/2 du equals t dt, and that takes care of the extra t dt, and this will be cos u sine u, so the whole thing will now be in u. And again, with definite integrals, I'm going to run the limits of integration through the transformation to create new limits of integration in the proper variable. Okay, so here we go. Integral 0 goes into here, creating u is 0. Square root of pi goes in here, and I square it, I get pi, so u is pi. Okay, there we go. And now I just replace all the variables up here with the appropriate expressions in u. So t dt is absorbed into the 1/2 du, and we're at the 1/2 on the outside, of course. And du will replace that, and cos u sine u. Alright, we're still not done because it's not so obvious what the antiderivative of cos u sine u is. You can kind of figure it out, but let's just say we have no idea what the antiderivative of cos u sine u is. As you actually may not. We should now try another substitution to see if we can affect a new integral which is still even easier to solve than this one was from this one. So in this case, I'll pick a new variable, pick v, as long as it's not u, I can't use u again. So v equals, I can really pick either one, I'm going to pick sine. Sine u. So therefore dv is going to be cos u du. But that's exactly the leftover material here, right? If this is the variable v now, then this and this, right, will become dv apparently. And cos u du is dv. So I can rewrite this integral, again, using another type of u substitution, but it's in a different letter, right? A v substitution. Play the same basic game. Sine u becomes v, and cos u du becomes dv. A very simple integral now, right? We know the antiderivative of this is 1/2 v squared. So we're done. So I need to run these limits of integration through this transformation again. So 0 into here gives me sine of 0 is 0. That's nice. The 0 values for limits of integration tend to be good to work with. But pi in here, sine of pi, well, sine of pi is also 0. So at this point, even without taking the antiderivative, we can already see that since these two limits of integration are the same, we know it's a property of integrals that the answer must be 0 at this point. Okay? Now surely it's pretty obvious anyway if you're to continue with this, right? Although we know this is 0, let's say we didn't know, right? And you continued the process, you get 1/2 and then 1/2 v squared here, evaluated from 0 to 0. So you're going to get 1/4 v squared evaluated across basically an empty interval. And if you just keep moving with the substitutions according to the fundamental theorem of calculus, you'll of course end up with 0 minus 0. Right? You have 1/4 0 squared minus 1/4 0 squared is, of course, 0 minus 0 is 0. So it's just faster to immediately conclude when you have a situation where the limits of integration are the same, that you have not found any area whatsoever because there is no width, you might say. There's no dimensionality to the interval over which you're integrating. So the answer has to be 0.